Assalamualaikum and hi. In this video, I will talk about special distributions. Okay, basically in this chapter, you will be introduced to um, some specific type of distributions. Okay, discrete and continuous. Okay, firstly, we will look at discrete distributions. Um, Something similar to what you have learned in the previous chapter. Okay, what is discrete distribution? It consists of values that a discrete random variable can assume and the corresponding probabilities. The probabilities are determined theoretically or by observation. Okay, so specifically for your syllabus, we will cover on binomial probability distribution and also Poisson probability distribution. So both binomial and Poisson distributions are discrete distribution. Okay, this is an example of a condition that you can consider as having a binomial distribution. Suppose that a certain fast food restaurant is giving away a coupon with every purchase of a meal. 20% of the coupons entitled to a free burger and the rest say better luck next time. 10 students order lunch at this restaurant. What is the probability that 3 of them win a free burger? Okay, as you can see, the question is trying to find out the probability that 3 out of 10 will get the free burger coupon. Okay, and you can do the calculation using a binomial formula. Okay, we can let x be the number of people out of 10 that win a free burger. Then the probability distribution of x can be constructed. Okay, basically we are trying to figure out the probability x equals 3 get the free burger coupon. In this section, we will learn that x has a distribution called the binomial distribution, which is one of the most useful probability distributions. Example, according to a survey, 65% university students smokes. 3 students are randomly selected from this university. Let X denote the number of students in this sample who does not smoke. According to a survey, 65% university students smokes. 3 students are randomly selected from this university. Find the probability that the number of students who do not smoke, okay, at most 1, from 1 to 2, at least 2, more than 1. Okay, so before we tackle on the binomial probability distribution, let us look at these inequalities first. Okay, when it mentioned at most 1, that means the probability that x at most 1, paling banyak 1, that means x is less or equal than 1. Okay, and then for the second one, from 1 to 2. From 1 to 2 means from 1 to 2. When we have the words from and to, we have the equality sign. That means including 1 and including 2. Okay, for the third one, at least 2. At least 2 maksudnya paling sikit 2. Paling sikit 2. Maksudnya X must be greater or equal than 2. And finally, more than 1, X greater than 1. And this is equivalent to probability of X greater or equal than 2. Okay, now let's see how to solve these questions. Okay, let X be the number of students who does not smoke, who do not smoke. Okay, and then we have S denotes smoking. S prime does not smoke. Okay, so since we are going to select 3 students, so we will have 3 level of branches. Okay, so this is the first level, second level, and third level. Okay, and then we can list all the outcomes. Okay, so this column is basically we call the outcomes. Okay, we can list all of the possible outcomes. Okay, and as you can see, all of these are smokers. So X is 0. Okay, and here you can see all of the students are non-smokers. So X is 3. Okay, and so on. You can check for each value of X. Okay. Okay, just to make sure that all of you understand how to list the outcomes. Okay, so for the first one, it's simply you follow the branch. Okay, so that's why you get S, S, S. For the second one, you follow, no. For the second one, it will be this way. So that's why you have S, S, S prime. Okay, let me show another example. Okay, let's say you follow these branches. Okay, that's why you have S prime, S, S, S prime, S, S. Okay, that's how you read your tree diagram. Okay, and then okay, from this tree diagram, we can we can construct the probability distribution. Okay, and as you can see, for a binomial distribution, the probability value is unchanged. For smoking, it will always be 65%. For non-smoking, it will always be 35%. Okay, and it will remain the same throughout the selection. Okay, there's no issue of replacement with replacement or without replacement. Okay. Okay, since in the previous slide we have this question, at most 1. Okay, this is equivalent to probability of X 0 plus probability of X 1. So you will get 0.2746 plus 0.4436. And that's 0.7182. And you can do for the rest of the question, probability from 1 to 2 probability at least 2, and last one, probability more than 1. But this is actually the same as the same as this question. Okay, they are the same because this is equivalent. Okay, what are the conditions of a binomial experiment? A random variable that represents the number of successes in a series of trials has a probability distribution called the binomial distribution. Okay, the conditions are a fixed number of trials are conducted. Okay, fixed number of trials. There are 2 possible outcomes for each trial. One is labeled success and the other is labeled failure. Okay, so it's either yes or no. Or in another example, it can be defect, non-defect. Okay, anything that you have only 2 possible outcomes. Okay, the probability of success is the same on each trial. Okay, the same goes for the probability of failure. The trials are independent. This means that the outcome of one trial does not affect the outcomes of the other trials. Okay, as I have mentioned earlier, the probability values are unchanged. For failure, it will remain the same, and also for success probability, it will remain the same. The random variable x represents the number of successes that occur. Okay, so this is just like what you have learned in the previous chapter. Okay, these are the notations. In a binomial experiment, the following notation is generally used. The number of trials is denoted by n. The probability of success is denoted by p. The probability of failure is 1 minus p. Okay, sometimes q is used to represent 1 minus p. Well, basically, probability of success plus probability of failure is 1. Okay, and take note of the letters that I've written here. It's small letter p, okay, for probability of success, and small letter q for probability of failure. X represents the number of successes that occur. Okay, let's look at this example. When an adult is randomly selected, there is a 0.85 probability that this person knows what Twitter is. Suppose we want to find the probability that exactly 3 of 5 randomly selected adults know of Twitter. Does this procedure result in a binomial distribution? Okay, well, it looks like it can be represented by a binomial distribution because you can write that 0.85 knows Twitter. Okay, and you can straight away figure out the other probability doesn't know Twitter. Okay, and then n, the fixed number of try is 5. And the question is trying to find the probability that exactly 3. So probability exactly 3. Okay, so basically we have all of the characteristics of a binomial experiment, a binomial distribution. So it is a binomial. It can be represented by a binomial distribution. Okay, methods for finding probabilities of a binomial distribution. There are two methods for finding the probabilities corresponding to the random variable x in a binomial distribution. Okay, we can either use a binomial formula or the binomial table. Okay, so let's look at the first method using the formula. Okay, you have the formula here where n number of trials, the small letter x, number of successes among n trials, small letter p, probability of success, q, probability of failure. Okay, compute the probability of x successes using the binomial formula where n is 6. Okay, so the formula is x equal x and choose x, and then probability of success power x, probability of failure n minus x. Okay, so you simply plug in into the formula. Okay, take note of the formula. You can only use the formula whenever you have the equal sign. If you have inequality sign, you must figure out different ways of using the formula. Okay, or maybe when you have inequality sign, for example, probability of x greater or equal 3. Okay, maybe something like this. It is more convenient if you use the binomial table. Okay, that we will learn later. Okay, so you can try to check on your own using your calculator. Okay, you have this function in the calculator. Okay, and the operation here is multiplication. Okay. Okay, and also try to get 0.201. Okay, and try to get 0.2013 for the second example. Okay, the second method is to use the binomial table to find the probability of x when x is 6, n is 10, and p is 0.5. Okay, you will have the first column for n. Okay, and the top row listing all the probability value, all the probability of success. Okay. Alright, so the answer is 0.2051. Okay, saya rasa ada kesilapan sikit dekat slide ni. Bila kita baca dekat table, kita bukan baca ni. Kita bukan baca equality sign. Okay, kita baca less or equal. Okay. Daripada table, kita hanya boleh baca untuk less or equal sahaja. Kita tak boleh baca greater than, greater or equal, equality kita tak boleh baca. Tapi kita kena ubah suai cara, kita kena ubah suai inequality tu supaya kita boleh baca dari table. Okay. So, saya rasa yang ni silap lah. Okay, maksudnya kena baca yang ni. Kena baca yang ni. Maksudnya kena dapatkan bacaan yang ni 0.2051 tolak bacaan dekat sini. Ada satu lagi bacaan dekat sini. Okay. Baru dapat jawapan. Dapat jawapan berapa. Okay. Ini baru jawapan untuk probability of X greater equal 6. Okay, maksudnya jawapan ni probability of X equal 6 adalah awak kena buat operasi tolak ni. Okay, compute the probability of X successes using the binomial table where n equals 2, p equals 0.3 and x less or equal 1. Okay, so okay, yang ni x less or equal 1. Maksudnya sama dengan probability of 0 plus probability of 1. Sebenarnya kalau awak tulis panjang dia macam ni lah. X equal 0 plus X equals 1. Macam tu. Okay, atau awak boleh tulis je macam ni terus. Terus simplify, tulis macam tu je. P of 0 plus P of 1. Okay, dan yang ni guna formula lah. Maksudnya untuk P of 0 guna formula, P of 1 guna formula binomial. Dan dapatkan jawapan 0.91. Okay, dan cuba juga tengok, fahamkan soalan kedua. Okay, dan dapatkan jawapan ni. Okay, seterusnya kita ada mean and standard deviation of the binomial probability distribution. So, kita ada formula mean dan formula standard deviation. Okay, standard deviation senang je lah. Square root of number of trials kali probability of success kali probability of failure. Untuk mean, number of trial kali probability of success. Okay, cuba buat soalan yang ni. Yang ni ada jawapan ke? Oh, tak ada. Okay, cuba selesaikanlah. Okay, cuba buat soalan ni. Exercise 1, exercise 2 dan exercise 3. Okay, itu adalah binomial probability distribution. Okay, that's all for today. Thank you so much.